Integration by partial fractions. In integration by partial fractions, what you do is you take a certain rational function, which is a polynomial divided by another polynomial, and you try to determine the integral of a set of factors that can add up to that same rational function. So, say we have the integral 1 over x squared minus 4 dx. Okay? So, this would be equal to a integral 1 over the first part, we'll say f1 dx, plus b integral 1 over f2 dx. Okay? Because there's 2 here. Okay, so x squared minus 4 is the same thing as x plus 2, x minus 2. Okay? So that means that this is equal to a integral 1 over x minus 2 dx plus b integral of 1 over x plus 2 dx. Okay, so we have our two integrals right there, which we got from here. So you're always going to put 1 in your numerator for your fractions, but this can be anything. Like this could be like x squared plus 4, something like that. Right? That could be x squared plus 4, and you would still leave this as 1. This and that, so this, you would use this to solve for. And then this, you would still use that. You would still use the same thing. Anything with this denominator, you would use this partial fraction. The only thing that changes are these two values, a and b. Okay, so we're going to use 1 for simplicity. Okay, so in this case, we're going to solve for a. So if we multiply everything by the integral of x squared minus 4, so if we multiply everything, multiply everything by the integral of x squared minus 4 dx, right? We're multiplying everything by the integral of x squared minus 4 dx. Then we're going to get the integral. Now, the integrals actually cancel out, right? So we're going to get 1 is equal to a x minus 2 times x squared minus 4, which is just x plus 2, x minus 2, right? Excuse me. So, and it's times x minus 2. So if so this is x plus 2 times x minus 2 over x minus 2 plus b times x times x plus 2 times x minus 2 over x plus 2. So the x plus 2 cancels out for the b, and the x minus 2 cancels out for the a. So now, what we're left with, right, what we're left with is 1 is equal to a times x plus 2 plus b times x minus 2, which is the other function. So you multiply it by the other functions that are not the one in the denominator for this part. So for a, the factor that's in the denominator is x minus 2. So in our equation to solve for a and b, we multiply a by every other function except for x minus 2. So if there were also the function like x plus 3, right, we would also multiply a times x plus 3, but we still would not multiply a by x minus 2. It's everything but the denominator. So what we're going to do is we're going to solve for a first by plugging in the value of its denominator, x minus 2, that makes the denominator 0. The value of x, that makes its denominator 0. So this denominator is x minus 2 in this factor part right here. So if we want to solve for a, we input the value of x that makes x minus 2 0, which is 2. So we're going to say 1 is equal to a times 2 plus 2 plus b times 2 minus 2, which is just 0, so that's nothing. So that would be a times 2 plus 2. 2 plus 2 is 4, so that's 4a is equal to 1. So a is equal to 1/4. Okay? And now we're going to do something with b. So what makes the x plus 2 0? Well, that would be... Well, what makes x plus 2 0 would be negative 2. So we're going to put in negative 2 here. So it's going to be 1 is equal to a times negative 2 plus 2, which is 0. So that cancels out. Plus b times negative 2 minus 2, which is negative 4. Negative 2 minus 2 is negative 4. So then we get negative 4b is equal to 1. So that means that b is equal to negative 1/4. Okay. So now that we know that, right, we can plug in our values of a. So this is equal to our values of a and b. So this is equal to 1/4 times the integral of dx, I'm just going to put it in the numerator, over x minus 2. And then b is negative 1/4, so it's plus negative 1/4, which is just minus 1/4, minus 1/4 the integral of dx over x plus 2. Okay? Because we substituted in our values of a and b. Now that we've done that, our last step is going to be to integrate these two. So the integral, so we're going to just do u substitution. So we're going to say u is equal to x minus 2, and then du would be dx. And then here u is equal to x plus 2, so du would be equal to dx still. So now we're going to be, so this is going to be set to 1/4 the integral of dx over u, of du, not dx, but this is an integration by parts, du over u minus 1/4 integral of, well, really we're not going to say u because that's kind of confusing. We'll say v, okay. Integral of dv over v. Okay, so this is equal to 1/4 ln absolute value of u minus 1/4 ln absolute value of v plus c. So then this is equal to 1/4 ln of absolute value of u over absolute value of v plus c. So this is equal to 1/4 ln 1/4 natural log of natural log. And u is x minus 2. V is x plus 2 plus c. And that's how we find our answer. Just like that.